Hello humans, we've been learning about the periodic table. Here's one of our classroom copies that has been color coded. We've got our noble gases on group 18. We've got our nonmetals. We've got our metalloids along the stair step, and everything else is a metal. I'm going to be looking at this and I'm going to try to show you how to do a basic electron configuration. You're welcome to look at your paper copy because it's the same one that I'm using. So we're going to start out by figuring out how many electrons lithium has. Lithium is in the first group and the second period. So there's two pieces of information there that we need to know. So the first thing we do is we figure out what period we're in, and we draw two circles around our symbol. The circles are going to represent where the electrons orbit in a traditional electron configuration. So two orbits because it's in the second period. Then we're going to look at the atomic number, which for lithium the atomic number is 3. The atomic number tells us how many protons there are, which are positive, and then if we're going to have a balanced atom, we have to have negative charges to balance those out, and that's going to be an electron. So we know there's 3 protons in the nucleus, and in the case of lithium, we're going to have 3 electrons. 1, 2, 3. So it turns out that every atom in its first orbit can only have 2 electrons. These little red dots represent electrons. It's going to have a negative charge. But the innermost energy level gets filled up with 2 electrons, so we have to put one more on another layer. And the number of energy levels is the period, and the number of electrons is from the atomic number. And we're going to get to what we can tell about the outermost energy level about the 3rd or 4th example. All right, the next example we have is helium. Helium is over here in group 18. And it's in period 1. So that gives us a lot of information, and we know that the atomic number is 2. So I'm going to put a 2 right here just for my own, just so I can remember. Since it's in period 1, we're going to draw 1 energy level. Since it is atomic number 2, we know that it's going to have 2 electrons to balance out the 2 protons. So there's an electron, there's an electron, and well, that's it. That's the whole model. So we've got the nucleus, and we know that the nucleus is going to have 2 protons and 2 neutrons, and then 2 electrons to balance out the protons. All right, let's do another one. This already looks like an orbit, but it's oxygen. So oxygen, element number 8, is in group 16. It's in period number 2. So we draw 2 orbits because it's in period number 2. It's in group, we'll get to the group part in a second here. Then we're going to add our 8 electrons. Now here's the thing. We have only been doing smaller atoms, but this one's got 8. But remember, the innermost energy level can only hold 2. Just like the lithium, after we fill that one up, we've got to go to the outside. So oxygen's going to have 6 more. 1, 2, 3, 4, 5, 6. So we've got electrons on the innermost energy level. There's only 2. Then we spill out into the next one. 1, 2, 3, 4, 5, 6. Total of 8. So we've got 8 protons, 8 electrons, and you already know how to calculate the neutrons, but let's remind ourselves, if the mass is 16, mass minus the atomic number, which is 8, equals 8. So we know there's 8 neutrons in there too. So in here we would have 8 protons and 8 neutrons and 8 electrons. There's your oxygen. Let's do another one. This next one is special because it's a noble gas. Remember, noble gases are officially in the non-metal category, but they are special. And I'm about to show you why, and this is just the beginning of our discussion about noble gases and why they're special. So argon is down here. It's element number 18. It's in, and it just so happens that it is in period 18. Oops, sorry, not period 18, group 18. It's in period 1, 2, 3. Group 18, period 3. It's a noble gas, so it has something special going on. I'm going to show you what that special is. So we're in period 3, so we're going to draw 3 orbits. 1, 2, 3. Excuse me. And we know that we're going to end up with 18 electrons to balance out these protons. You know what, while we're thinking about it, let's just say 18, wow, 18 protons. Argon is, excuse me, argon's mass is 40 when we round it. 40 minus 18 equals 22. So there's 22 neutrons. So we've got 18 protons, 22 neutrons, and we know that we're going to have 18 electrons to balance out those protons. So let's go ahead and get started. On the innermost energy level, how many electrons? 2, that's right. On the next energy level, and we haven't done this yet, the next energy level can hold up to 8. You'll notice I'm doing what I call the crisscross lug nut pattern. 1, 2, 3, 4, 5, 6, 7, 8. It just helps me balance out my model. All right, so at this point, we've got 2 on the inside, 8 on the next layer. Now the next layer is full. So this one can hold 2, this one can hold 8, but then it's full. Every atom that has 2 orbits, when we get 8 in the second orbit, we start to spill over into the next one. So 2 plus 8 is 10. We need 8 more. 1, 2, 3, 4, 5, 6, 7, 8. So now we have 2 plus 8 plus 8 more. It turns out that this one now, for our purposes, is full. So argon, because it's a noble gas, it's over here on the 18th column in the 18th group. When each one of these gets filled up, you go to the next period and start over again. So it means we have to have another orbit or another energy level. So helium only has 1 energy level. Neon has 2, and they're both full. Argon has 3. 2, wow, we're getting a little crowded there. So helium fills up right there. Neon, the first layer is full, and then there's 8 on the next layer. That one's full. Argon, this one's full, this one's full, this one's full. And what happens is the noble gases, because all of their energy levels are full, actually it's really just the outer energy level, but because their outer energy level is full, these guys do not take part in chemical reactions. Under any normal circumstances, if you have argon, it stands alone. You can put it in a fire, you can throw the most reactive elements at it, it's just going to hang out. It's noble. All right, let's try to make some more, but remember, the number of periods equals the number of orbits that you draw. The atomic number tells you how many electrons you're going to add to your model, and the innermost energy level gets 2. Second one can have 8, and the third one can have 8. Let's see, is there anything else? Oh, there's one more thing. So we're about to learn about Roman numerals, and I want you to write this down. I equals 1. I equals 2. I equals 3. Oh wait, we've done this already when we learned how to read the clocks. IV equals 4. V equals 5. VII equals, whoops, that's 7. VI equals 6. And VIII equals 8. This is going to be handy, and these numbers are going to show up on top of our groups. All right, let's try it on the board.